So this video is over 1.5, the graphing calculator, how to use it to find your x-intercepts. Now remember, x-intercepts, the other words for those are solutions, zeros, and roots. Now we've done this problem before when we did section 1.5, taking the square root on both sides. So this was dropping an object. Remember, here's the formula that we need to use to create our function. We have h equals negative 16t squared plus h naught. Okay, h is your height. Negative 16 always stays the same. You always have t squared as well as t is time. And h naught is what we call the object's initial height. Now we've done this problem before, but let's see if we get the same answer as we did last time. So it says, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? Now remember, when it says how long does it take to hit the ground, that's where we need to find our x-intercepts. Now in this case, we have to see if we have one or two intercepts and figure out what that answer is. Now, in order to figure it out, we need to write our function. So our function here is h equals negative 16t squared. Remember, this always stays the same. Now, if we look, our h naught, which is the object's initial height, they dropped it at a height of 50 feet. So now we put plus 50. So what we're going to do is get our graphing calculators, okay, and we're going to go to y equals. Now if you have anything in here, go ahead and clear it. And what we're going to plug here is that negative 16, so make sure you put a negative sign, so negative 16. Now in this case we don't have t, so you just have to use x, which that's okay as well. So we have x and then squared, and then we do plus 50. So let's go ahead, let's change our window, if it's not already, to the standard. What I always like to use is negative 10 as my x-min, positive 10 as our x-max, scale of 1, and once again negative 10 for the y-min, and then a positive 10 for the y-max, and then our scale of 1. Once you've gotten that, go ahead and graph it. Now remember, if I'm going too fast, make sure you can always pause the video, or you can kind of go slow down and go slide by slide. Now if we look at our graph here, right, some of it's cut off. Well, it looks like our window is not incorporating everything that's on our graph. So let's go ahead and let's change our window. Now here, this is kind of more of just a guess and check. So you might have to do this multiple times, okay, to figure out what's the correct window. Now look like here that our y value, particularly the y max or the positive values, we might need to get a little bit more there. So let's go ahead, let's make our y min, I'm going to make it negative 5. And then let's go ahead and make our y max at 50. Now, I don't want all those little lines here, so I'm going to make my y scale 5 here. Okay, let's go ahead and let's graph this and see if this works better. And it did. Now we can see the top half of our graph. Okay, so now let's draw a sketch here. Okay, so it told us that we need to figure out the time that it takes for the container and the egg to hit the ground. Remember, hitting the ground means that we're going to find the x-intercept. Now we're talking about time. Would it make sense to have negative time? So have like this t or x value over here? No. So when we do this problem, really we're only going to have one solution. And this solution is going to be part of the, what we call the first quadrant, our positive part. So let's go ahead, we're going to sketch only the positive part. But in order to do that, let's rearrange our window here, because all I want is the positive area. So I'm going to go back to window. Now, because I want positive, I'm only going to deal with my x-axis. So I'm going to make my min 0, because I don't care for the negative. And then I'm going to make this a little bit smaller. We're going to make it 5. And now let's go ahead and graph it. Now this looks a little bit better. So now we can find our x x-intercept a lot better. So sketching it, remember, it does not need to look perfect when you're sketching it. So remember, I'm only doing the first quadrant, so I make my graph look like an L. Now remember, we kind of start from the very top, and then we hit here, and then kind of just goes down, right? Now, right here, this is what we're trying to find, our x-intercept. To find that, we're going to go to second, then trace. And here, remember that we want to find our x-intercept. Other names for it, 0. So in your calculator, you're going to do number 2, which is 0, and press enter. Now, just like min and max, they're going to ask for a left and right bound. Now, for here, this is what I highly suggest to know, well, which one's my left and which one's my right bound. I would draw a line that goes right through your x-intercept. And here we're going to ask, well, what is the left side of this green line here? So we look here and look to the left. Well, it looks like anything that's above the x-axis, that's what we would consider our left bound. So that means we're going to put our cursor anywhere that's above the x-axis. So let's go ahead and we're going to do that. So we're going to move our cursor that's just somewhere above the x-axis. Okay. Well, here's my cursor, and it looks like it's above the x-axis. So I'm going to press enter. Now to find the right bound, okay, we got to figure out, well, what's the right side of this green line right here? Well, if we look here, it seems like anything that's below the x-axis, that's what we would probably consider our right bound. So now on the graphing calculator, we're going to now put our cursor, now we got to use our right arrow here, put our cursor somewhere below the x-axis. That means our y values are going to be negative. And then going to press enter. Now remember, whenever I ask you to guess, you just press enter one more time. And then here, our x, that's what we're looking for, our x-intercept. So let's go ahead, we're going to round to, let's say to the hundredths place. So it looks like our answer is going to be at 1.77. So here, writing our answers, now remember, in this case, we're doing t for time, okay? And we said 1.77. Now remember, because this is a real world problem, we have labels, and it's going to be at seconds. So it took the container 1.77 seconds to hit the ground. So you can also use a graphing calculator to find your x-intercepts. And you can do this for any type of problem, especially for the word problem. Make sure if you have any questions, you can always email me or come in before after school. And so you will use this information for the homework dealing with the word problems. Because remember, with the word problems, we will probably only deal with the positive half of a graph. So make sure you really look at this and try to get an understanding, because this will help you for the word problems on the homework.